Welcome to the walkthrough of Assignment 5 for CS253 in the fall of 2023. The purpose of this assignment is to deepen your experience using Java's functional programming features and Java's reactive streams. In particular, in this assignment, you'll develop an app that uses the RxJava implementation of the Java reactive streams specification to obtain, transform, and store images asynchronously and concurrently in a pool of threads. Like the earlier assignments, the code you write has a GUI and runs as an Android app. Please use this GUI along with the unit test discussed below to help test and debug your solutions. The following resources may be helpful in completing this assignment. Videos on the Java reactive streams and RxJava appear in my YouTube playlist here. Tutorials on RxJava appear here and here. Naturally, we'll cover all this material in class, which will be available in my YouTube CS253 playlist here. The Image Crawler app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 5, however, you only need to be aware of the following directories: Image Crawler source main Java edu Vanderbilt Image Crawler crawlers, which contains the skeletons you need to fill in, as we'll discuss below, and Image Crawler source test, which contains a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 31, so you need to select an emulator that uses an API greater than or equal to 31. I recommend API level 34. You should already have an Android emulator installed, of course, but if you don't have one, you can create one by clicking the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Don't change the overall structure of the skeleton, just fill in the to-do tasks and do not delete the to-do markers. In particular, you'll need to finish implementing the following to-do tasks for this assignment in the image crawler folder. First, you need to implement the to-do tasks in crawlers rxflowable crawler.java in various methods to obtain, transform, and store images. This class uses RxJava flowable and parallel flowable operators to perform an image crawl asynchronously and concurrently, starting from a root URI. Depending on the parameters used to run the app, images from HTML pages reachable from the root URI are either downloaded from a remote web server or read from the local file system, transformed, and the transformed images are then stored in the Android device's local file system. You'll also need to complete the to-do tags in the commonstudent.kt file to set the type field to include just graduate or undergraduate, depending on which version of the assignment that you're implementing. The bulk of the code for the app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the sequential loops crawler.java file. You'll therefore convert this Java 7-based class to the RxFlowable crawler class that uses RxJava. Your solution should use no loops or if-else statements in this assignment, and instead use RxJava operators and reactive programming features. Likewise, there should be only one call to blocking get. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Skeleton code for this assignment is available here in my GitHub account. Now that you've set up your GitLab account, you can pull this skeleton code into your repository, read it carefully, and complete the to-do markers. Unit tests in the image crawler source test folder are provided to increase our confidence that your implementation is working as expected. It's essential that you use the Android Studio GUI to run these tests locally on your computer as described here and shown later in this video. As usual, testing only demonstrates the presence of bugs and not their absence, so don't rely solely on the test to detect problems in your code. In particular, I'll also provide videos that walk through frequently made mistakes that you should address. Please address these issues prior to your submissions to streamline our program assignment review and assessment process. Assignment 5's complexity level is similar to the Java Completable Futures crawler class in Assignment 4. In particular, the asynchronous nature of RxJava and reactive streams may take some time to get accustomed to, so please start the assignment soon and ask questions in class, office hours, and on the discussion forum. As usual, the app, image crawler skeletons, and unit tests are extensive, though you don't need to understand them all to complete your solution successfully. Now that we've walked through the specifications for Assignment 5, let's go ahead and take a look at the skeletons. As usual, we'll come down here and go into the main Java edu Vanderbilt Image Crawler crawlers folder, and there'll be a number of different skeletons you need to fill in. First, you'll need to fill in the skeletons you wrote in earlier assignments like fork join crawler, fork join EX crawler, sequential streams crawler, parallel streams crawler, and most recently, of course, completable futures crawler. Note that we often make a few changes to the tests from previous assignments in order to make sure that you're doing things correctly. So you may need to make a few changes. If you end up getting some issues with testing problems when you run the old tests in your assignment, that probably means you need to update them. And if you have any questions, of course, don't hesitate to post them on Piazza or come ask in office hours. The new skeleton you'll need to implement is the RX Flowable Crawler. You can see here, this is the image crawler implementation strategy that uses the RxJava Flowable and Parallel Flowable classes to perform reactive image crawling starting from the root URI. And we'll see as we go through the skeletons, there's a bunch of things you need to fill in here. Let's start by taking a look at perform crawl. In this implementation, you should replace return 0 with a solution that performs the main crawling operation. This method should call a helper method. This is the helper method that will initiate the crawl process asynchronously, and it should also include a number of RxJava operators that handle errors, count images, and block until the flowable stream completes. And you may also need to do a little casting of the result to come back to be an int, as you can see here. Let's now go down and take a look at the crawl page async method, which is going to download and transform all the images on this page, the page URL, and then recursively download and transform all the images on each of the page links within this page. And in order to do that, of course, it'll call a bunch of other helper methods. So to do this, you need to fill in the method implementation replacing return null with your solution that will handle asynchronous crawling of a single web page, this one, of course. And this method should employ an RxJava operator first to filter out a page if it exceeds the depth, here's the depth, or has already been visited. That shouldn't be too much different from what you did with parallel streams. It should then use several RxJava operators to call helper methods, defined below, of course, that will map the URL to an HTML page. There's a method that does that, which is part of the image crawler class, superclass. And then it'll also process the page to retrieve the images asynchronously. And as you can imagine, you'll have to call some of the methods down here below. So let's go down and take a look at some of those. Here's one of them, images on page and page links async, which, as you can see, returns a flowable that will emit the transformed image objects that the crawler page parameter is got, and also the link pages that are reachable from that page. And so here you'll replace the return null with a solution that processes the images from this page, the parameter, and its link pages. And this method should merge, keep in mind what we talked about in class with merging the image streams from the current page and its links, utilizing the appropriate RxJava operator that will call two helper methods to process the page asynchronously. So you need to call a couple of other methods defined below and then merge the results back together. So let's now go take a look at some of the helper methods that images on page and page links async should call. You can see the first one is images on page links async, which will find all the page links on this page parameter, and then it will crawl each page that's linkable from there and then download and transform all the image objects that it discovers. And in order to do this, you're going to replace return null with your solution that finds and processes the images from all the pages that are linked from the page parameter. And this method implementation should use RxJava parallel flowable operators to recursively explore the links on the page and apply the appropriate image processing to each. So the key thing is here to call this recursively. So you should think about what you're going to have to recurse on. Here's a hint. And you should also keep in mind that because you're using the parallel flowable operators, when you're all done with the recursive processing, then you want to turn it back into a sequential stream, sequential flowable, by using the appropriate conversion operator to convert the parallel flowable back into just a good old flowable. Let's also take a look here at images on page async. This method will find, download, and transform all the image objects on this page. And in order to do this, you replace return null with your solution that processes the image on a single page, which is this page, of course, the parameter. This method should also use RxJava parallel flowable operators to handle the extraction and transformation of images. In particular, it should use the compose operator, which is a really advanced feature that allows defining your own special operators. You should use compose in conjunction with map not null, we'll look at that in a second, to get or download an image, which is then transformed asynchronously using another helper method called within an RxJava operator. So you'll have to do a little thinking here. This is a little tricky. And make sure that you also convert the parallel flowable back into just a good old flowable with the appropriate conversion call. Now, this map not null call that we're talking about is actually defined down here. And we need this because we want to skip any null values that may be generated in an RxJava stream. And for a variety of reasons, the map method, the map operator in RxJava doesn't handle nulls by default. So what we do is we make our own sort of user-defined operator called map not null, which is going to apply the mapper function. And if it gets back something that's null, it'll return an empty flowable. Otherwise, it'll just return the result as a flowable. So we use this to define our own custom operator, and then we're going to end up calling this in the context of images on page async using the compose operator. So it's a little bit tricky, but this will be fun, and it'll give you a sense of learning how to do your own custom operators in RxJava. The get or download an image, that should be a hint to take a look at the appropriate helper method, and then you'll have to transform those things asynchronously using another helper method, and of course that helper method is this method, transform image async. And this will apply the current set of crawler transforms on the image that's passed in, and it returns a flowable stream of all successfully transformed image objects. So let's go ahead and take a look at how this method is implemented. As you can see here, you replace return null with the solution that transforms the given image using all the transforms that are available. Of course, there's a field that will give you all the transforms. And this method should apply these transforms once again using the RxJava parallel flowable operators. And that will create a new cache entry and filter out any image transforms that are already in the cache. This should look very much like what you did for Java completable futures, for Java parallel streams, just using the RxJava reactive programming operators instead of the completable futures or streams operators. It should also use the compose operator in conjunction with map not null, which we talked about down here, to handle nulls, and it will then apply the transforms on each image. Once again, after it's done doing that in parallel, it will then convert the parallel flowable back into a flowable using the appropriate conversion operator that's defined in RxJava. So that's basically what you need to do. There's a little error handling method here I defined. You don't need to worry about that. It's just provided for you. And I provided you with map not null as well. It's a little tricky. It'll take some doing. I strongly recommend you watch the videos on RxJava before you start trying to hack up a solution. Otherwise, you will get lost very quickly. And in particular, it's important to take a close look at all the parallel flowable videos, because that will give you a better understanding of how those operations work and how to convert a flowable into a parallel flowable, and then from a parallel flowable back into a flowable. So make sure you watch the videos, make sure you post questions on Piazza, and come in to office hours if you have any questions. Now that we walked through the specification and skeletons, let's show how to run the unit tests. As you can see, we go into the tests folder under image crawler, click on edu Vanderbilt image crawler crawlers, and then go ahead and right click and run the tests. As always, there's tests that test all the different implementations for the different assignments we've done up to this point. And you can see if everything goes well, you should get green check marks for all the different test runs. Just a quick note here, you can see we've got the completable future crawlers, crawler tests, the fork join crawler tests, the fork join EX crawler tests, the parallel streams crawler tests, the sequential streams crawler tests, and finally the latest and greatest Rx flowable crawlers tests. And you can see there's about 7 or 8 tests for this particular implementation. Keep in mind, of course, that you need to make sure you copy all of your code from the previous assignments so that you get green for all the different test runs. There may be some additional changes you have to make in order to make sure that the older tests pass, because we've continued to improve them in order to demonstrate newer and better ways of doing the implementations. As always, if you run into any problems, let me know. And please take a screenshot of running your tests so I can see at a glance whether things have gone wrong, and make sure to put that image in your assignment 5 folder at the top level.